We've already covered synthesis, which is putting two things together to make one product. Okay, we already talked about decomposition, taking one thing, breaking it apart. This is called single replacement reaction, and sometimes synthesis gets confused with single replacement. So be real careful with this. Here's what you're looking for. You have an A plus B, or AB plus C gives you AC plus B. What does that mean? You have a free element plus a compound, giving you a free element and another compound. Okay? You're going to look for you're going to have to know your charges. So remember, do your brain dump when you get a test or something. Shared charges are going to switch. What does that mean? Your positives are going to switch your positives, and your negatives will switch your negatives if you have to switch negatives, okay? And it's going to be the free element that is going to drive everything. All right, so make sure you're writing this down that I'm saying. If you need to back it up, okay? You will be given an activity series. It's a chart that we'll give you in class. I don't have one with me on this video because it would be backwards. So I'll give you one in class, and you'll have one to use with this video, okay? It's also going to be given on the test. You don't have to memorize this one, okay? So you just need to know how to read the chart, and we'll go over it in class some more, but I'm also going to kind of describe it in this video. The higher the free element is on the chart to the one it wants to replace, if it's higher on the chart than the one it wants to replace, then there will be a reaction and it'll switch places. If it's lower on the chart than the one it wants to replace, there will be no reaction. Okay, nothing's going to happen. You can stick it there all day long and nothing's going to happen. Okay, so let's jump right in and see what's going on here. Okay, so you can see that we have a free element. I'll use FE for free element. Okay, we have a free element and a compound, water. So I put sodium in water, and will it react? Well, we have to find out what charges we're looking for. We're looking for cations or anions because there's two activity series. There's one for the halogens and there's one for the metals. So we need to know if it's the metals or the halogens that want to do it. So this is a positive charge. This is a positive charge, and that's a negative charge. So we're going to see if sodium can replace hydrogen in water. And if you look on your activity series and do it at home, because I gave you one to take home, if you look, you'll see that sodium is higher than hydrogen on the chart, okay? So it is going to replace the hydrogen in the water. So hydrogen is going to come out. That leaves sodium going with oxygen because we're going to switch partners, switch that partner out, okay? So now you have to do what we've done in the other ones. You have to see if your free element is a diatomic, and hydrogen is. So it's going to be a 2 here. Sodium, you have to check your charges, is a +1. Oxygen is a -2. So you have to drop your charges, crisscross, okay? And then you have to balance. When we balance this, you get a 2 to 1 to 1 to 1 ratio, okay? So what we did is we're looking on our chart to see if the free element is going to replace the same charged element on the other side in the compound, okay? The ion, okay? So if we have a cation, it's going to try to change places with a cation. Let's take a look at this next one. You have calcium nitrate, and then you have gold, okay? So free element and a compound. Okay, so we're going to look to see if the free element can replace the calcium. What happened here is a sodium replaced the hydrogen, okay? So we have to look on our chart, and if you go and look and you find your free element, gold, it's the lowest one on the chart. Calcium is way up here on the chart. So gold cannot move up. So this is going to be a no reaction. You could stick gold in this all day long and it does nothing. It won't do anything, okay? So those are the ones for the activity series that have the most elements in them. So now let's take a look at this last one, and this video will be pretty short because you just need to practice it, and I'll have a few on the page. You have chlorine and potassium bromide. Okay, so we're looking to see if the free element will replace anything in the compound. Okay, so you look to see, and chlorine you know has a negative charge, potassium's positive, this is negative. So we're going to try to see if chlorine can replace bromine. So there's two ways to look at it. There's an activity series that I believe it's on that chart, but if not, you can look in your periodic table and look at your halogens. If the halogen is higher than the one it wants to replace, then it will replace it. So if you look, chlorine is higher than bromine, so bromine is going to get knocked out, and then we're going to put the potassium with the chlorine, and remember, positive then negative, okay? And you check your charges first. I'll do that first, and they're going to balance out that way, so I mean they're going to be okay, they're the same number. But then we have to look to see if our free element is a diatomic molecule, and it is. And then when you balance this, it's going to be a 1 to 2 to 1 ratio. Okay? So 1 to 2 to 1 to 2 ratio. Okay? So if you have any questions, please write them down. Bring them to class. On the other side of this video, on the other side of this paper, you'll have double replacement reaction. It's similar to this one, so just keep that in mind. Okay? I'll see you in the next video.